I'm delighted to see so many people here today. I'm also delighted to see some people I remember from working in ESB. My link with Offaly, I guess, is that I spent 5 years down here from 1987 till about, 92, working in for Manpower Station. So Larry de Waal from Holland, from the Netherlands, said earlier that there's a transition going on, and I'm a passionate believer in that transition, moving from peat-fired power stations to wind. From a personal perspective, I guess I have 6 children, and I reckon that qualifies me to talk about a certain number of the stages of life cycle management. So here goes. I guess there's a number of key elements to asset management, and I'm not going to bore you, so this will be pretty short. I've highlighted 2 of them. We talk about objectives. You know, what kind of objectives do you want from a wind-fired power plant? What's the workload going to be, and what kind of strategy are you going to employ? I'm obviously not going to talk about all these in detail. We then go through resource structure, and I guess the point of today is to understand the implications of operations and maintenance for the Midlands. So I want to focus on workload and resource structure. But there are other elements like work planning and control that was spoken about so eloquently by Donald earlier on, and the administrative structure, all the safety requirements, etc., that are needed, and finally the control systems that need to be put in place. I can't talk about all those today. And in actual fact, when Andy asked me to speak for 10 minutes about asset management, I reckoned that would about sum up all I knew about it in the first place anyhow. So, in asset management, I like to classify workloads into 3 or 4 different types. First line maintenance, which I'd call local and remote response. Scheduled maintenance, which is maintenance that needs to take place on our wind turbines to make sure they're safe. So that type of work includes establishing that all the bolts on the towers, etc., are tight, that all the components are being greased, that the grease is in good condition, that the oils that we use, etc., are in good condition, and that the schedule, that the main components aren't showing any obvious signs of wear and tear. There's also second line maintenance, which happens when smaller components fail, and they do tend to fail, things like yaw gears, etc., or small electrical components in our machines. And then there's third line maintenance, which is the heavy lifting type maintenance that does need to happen from time to time. Gearboxes do fail, other components do fail, main bearings and direct drive machines may fail, and certainly, over time, the repairs on blades need to take place, and in fact, certain blades will need to be replaced from time to time. What I've done here is to look at first-line local events, and the reason I put this up here is just to explain some of the context of the numbers that I'm coming up with. What I show here is a distribution of the number of days in a year when we'll have a certain number of events from 400 turbines. I picked 400 turbines because it's about, it could be up to 1,200 megawatts or even larger if we go for bigger wind turbines. But picking a typical 3-ish megawatt turbine and 400, we're talking here about 1,200 megawatts, which would be about 1/3 of the number of turbines onshore that's projected with this project. You can see here that with those 400 turbines, we could have 5 or 6 events for the majority of days in a year. So for 60 days or 65 days, we'll have 5 or 6 events. And each one of those events will have to be responded to by an operations and maintenance team, which will typically be 2 or 3 people. And if we're going to do this like a power station, we want the response to be reasonably quick. We don't want a machine to fail on Friday evening at 5 o'clock and for us to be waiting around until Monday morning at 9 o'clock for somebody to respond to that. We'll need them to be available to do that work. So despite the fact that, when you look at it and you sit down on paper and you say, well, we need X and Y number of people, we actually need people who are going to be on call and available at sometimes unpalatable times of the day. But that's what we in the power business do. So what I've done when I worked out the maths for this 400 turbine notional project, which is about 1,200 megawatts, is to establish how many O&M people we would need to maintain a consistent availability in around the 97-98% mark. And to do that, we'll need between 20 and 30 technicians to undertake first-line response. And a number of those will be shift-based, and it's up to us to decide, or up to the people themselves to decide how they're going to organise that work. But there is going to be first-line response, and it's going to be shift-based. Certain people are going to be on call. We'll also need overhaul and service teams, and those service teams will use about 30 personnel. And then we will have certain specialist teams. They'll be involved in blade repair work, certain preventive electrical maintenance on medium voltage work and that type of thing. And they'll be a relatively small group, somewhere between 10 and 20 people. We'll also have administration personnel, health and safety personnel, and that number would be in and around the 15 personnel. We'll need specialists who work on collector systems, underground cables, and small elements of the electrical balance of plant. And that will be a 5 to 8 personnel team who could also carry out certain of the isolations that are required. And then let's not forget civil works. A lot of our turbines are going to be off-road, and they're going to be built on wind turbine grade roads, and we're going to need personnel to go and maintain that circa 400 kilometres of access roads that we'll need. And then, and we're talking about Donald, for this size of a project here, we'll need 3 to 5 people, just looking at the metrics, looking at our KPIs, looking at how equipment is performing, and doing certain other work like condition-based maintenance. And then support services. We're talking about all these types of services that will be required. Crane lifting support, stores and stores management, safety equipment checking and inspection, safety and refresher training, the likes of the arch training that's carried out up north. We're going to need that kind of thing full-time in the south, or we're going to need to expand those facilities throughout the country. Electrical motor repair shops, gearbox repair shops, insurance inspections, condition monitoring, the list goes on and on. But there will be certainly between 30 and I reckon 80 overall personnel required when we look at the project in its entirety. So when I looked at the project, I asked myself, how would this be configured? Remember, what we need to do primarily is to have reasonably fast response. We need flexibility in terms of how quickly people can get to a machine that's broken down, and also to maximise quality of life, to ensure that people aren't travelling too far to get to work in the first place in the morning. For a project of this scale, we'd be looking at 3 relatively large onshore bases, servicing a cluster of 400-ish machines, and each of these bases would employ somewhere between 90 and 120 personnel. We'd have one central support service employing in and around 15 to 25 personnel in this stores, logistics, safety and central admin role, and that number could increase depending on the number and the different types of wind turbine that we'd be using. Obviously, the larger the number of suppliers, the more complicated this whole process becomes. Additional direct employment, as I outlined, somewhere between 25 and 35 personnel. So overall, in my view, to support 4,000-ish megawatts onshore in operations and maintenance, we'll need 350 full-time people for in and around the 20 to 25-year period. I just wanted to give you a sample of what might happen with an offshore element of a project like this. We have huge experience, and we've developed some significant asset management strategies for offshore. Obviously, in 10 minutes I can't really talk about it, but we've developed offshore strategies for our projects in Scotland, in Germany, and in a number of projects we have in the UK. There are a number of options for offshore operations and maintenance. Currently, my estimate would be that for 200 offshore wind turbines, which would provide somewhere in the region of 1,000 to 1,200 megawatts, we're talking about an ops team of somewhere between 80 and 100 personnel. Additional to all these things, and for this project, we're going to need specialist support for HVDC connections to the UK, etc. So overall, my belief is that the offshore numbers for the Energy Bridge project as it stands are in the region of 120 persons. I hope that gives you a flavour for O&M, so thank you very much.